record. All the video and audio you see will come from what the tablet sees, so that's basically whatever's on the screen and then any audio that it captures. So it's not tied into the room or anything like that. There is also, I guess we can kind of pop through these really quickly. The student reading guide is one that I suggest you guys check out. It's a Google Doc that I make, and I'm going to update pretty frequently. So for Wednesday's class, what are we going to be doing, and what's the suggested reading before it? Monday's class, what are we doing, and suggested reading before it? Friday's class as well, what labs you have. And then there's actually a FAR column over here. Under in the syllabus, I have a suggested purchase of a book. I don't know how much it costs. I know at Delaware is $35. You might be able to find it on eBay or some other site. But there's this POGL book called Chemistry Guided Inquiry. I'm printing off a number of activities from it that we will use in class. We're only using about a third of the activities. It's a really good resource. You'll see some of it. It's actually not the same one today. On Friday, we'll be using the first activity from that book in class. I'm going to be printing out the pages. But there's a lot of other ones. So additional suggested POGL activities that we won't be doing in class. So I'm going to be putting here a number of different ones. And they're kind of like a worksheet, but it's very structured and guided. And it really helps kind of wrap your head around some of the concepts. So that's what this FAR column is over here. These are the sections of your book that are going to be in the homework. I'll be updating those as we go throughout the course. So that's just linked from student reading guide. Information is going to have our syllabus. This is the pre-class survey that we need to have done by Labor Day. Content is a syllabus. I'll be posting all of our class slides in here, so if you want to go back and look, you can do that. Here's links to Cengage if you have not been able to register yet, iClicker Reef, and then this is another link to the YouTube pages that's also here. And this is really where I want you guys to post discussion questions. So if you have a question like, I can't find the ebook, would be a great one to do. That would go under course logistics. If you have a content-specific question, that would go under content questions. If it's something that's just for you, email me. If it's something you think other people in the class might have an issue with, might benefit from seeing the question, please post it here. I'm still trying to figure out how to get it to notify me, but once it does, as soon as I get an email from that, I'll go answer it, but it's not going to be a private answer, it'll be a public answer, so other people that likely have the same issue can also go to the same place and learn from the challenges and struggles that we're having. And that way I don't answer the same question 58 times. All right, I think that is it. If you want to send an email, you can also do that here. You can send it to multiple different people, which is kind of cool. Not just to the instructor, you can send it to different groups or people in the class. In the groups, not in the back row, please. Thanks. All right. With that said, does everybody have their iClicker Reef app or a computer with iClicker Reef? So as you register, I want you to include your T number, and then I think I'm also going to have you register or click on a link within our Blackboard course and sign in, and that'll link the two accounts. But if you have your T number in there, it'll help to make sure that we sync and that you get credit for the participation you do. You have a question?
Yeah, I couldn't sign up. I was trying to do it in the app.
So it's iClicker Reef. There's multiple different apps, and iClicker Reef should be able to let you sign up for a free trial. So I would, maybe as we're doing this next question, I can see what you're working with. And that is ridiculously large. That's crazy. It takes up like half the screen. All right, our first clicker question of the semester.
When I downloaded the app, it already said there was an absence reported.
Yes.
Yeah.
Okay, don't worry about that.
Okay, I was just trying to make sure that I was
Yeah.
Okay, so we're using iClicker Reef. Once you log into iClicker Reef, you should be able to choose this course, CHEM1402, Section 10 at UALR. If you haven't been able to get in, talk to your neighbor. This should work on a smartphone, it should work on a tablet, it should work on a computer, any of those devices. And when you have an answer typed in, obviously you have to work the problem, and then you have to type an answer and hit send, and it'll send it to me. Right now I have 0 responses, which is fine, we just wrote a question, but that number should change. If you have technical questions on this, go ahead and raise your hand. You are welcome to work with others on this question, but I suggest first you try to frame the question on your own before you work through it with someone else. Is anyone fluent in LG? Does anyone speak LG? The phone game. I want you to participate in that. Got 17 responses. Technical questions, raise your hand.
No, like
Okay, if you watched the video class and you did some of those problems, there was a very specific way that I outlined that you were going to work through this. That's how I want you to do this. I want to see your work. Everyone have your work written down. Yes, it's a digital poll that you're entering your work, your final answer. I'm going to be walking around, and Sam is as well. And we're going to be looking to see if you lay out the conversion factors and show how to use them like we did in the video. That's the whole reason you watch the video. And you can ask them if
where are the okay, it says no arrows so they're blurry squares. I don't get this. And then there are no squares, no circles, no triangles, nothing. Oh, I get it.
You don't really know like stars or circles. Trying to find the amount where here. Yeah, and they would think what's relevant. Yeah.
So basically it's like going from
Either one of us. So we're just not changing. No, I was saying you don't need there.
Right, but I want to see it all written out. So everyone's off the screen.
I wrote down the conversion facts.
So
You have to square areas, so I line it up. So that it will cancel out. Like this, I use this conversion factor to cancel out squares. And then this conversion factor to cancel out triangles and give me arrows. And then you just multiply multi-step conversion.
First thing I have is a triangle.
Yeah, in order to cancel out, you just switch it to where the ones you want to cancel out are the bottom.
That's how they get your kids. It looks like my
So let's look at the process. How do I... It's just killing me how big this thing is. Alright. So if you didn't get a chance to watch the video for today, that's all good. I got to figure out how to make sure it's very obvious that there's a video I want you to watch. And so the video was basically walking through how we take this type of information. So it should be in OWL. It should be listed as week 1. Raise your hand if you were able to see the video. Okay, so some people were, but it doesn't show up in the list of homework assignments. I don't know that it was listed as due yesterday. Maybe that's a problem.
You had to go to all the signs available.
Okay.
I just straight couldn't find it.
Okay. So maybe if I put a due date on it, maybe it'll pop up because it wasn't really due. It's a video you watch. It's not like you do anything, so I didn't put a due date, but maybe that was my fault.
What if we make the quiz in the video?
What if you what?
If we make the quiz?
So the credit came from the quizzes, but I wanted you to use the approach that we're going to discuss now. So I'll go through it now because it sounds like everyone didn't get a chance to see the video, so we'll kind of talk through that.
Can we retake the quiz? If we didn't?
Oh, you didn't get to do the quiz. So in the future, no. For today, I'll probably extend the deadline because people haven't gotten into the platform and that kind of stuff. So I'll extend the deadline until midnight tonight. Does that sound reasonable for those who haven't gotten into Cengage yet?
Yes.
If that doesn't work for you, let me know. But let's see if I can get rid of this. This is my first time using this projector, and the screen resizes, so I'm going to close that for now. Hopefully that'll get out of the way. Come on. It's my whole screen's frozen, that's why. Okay. That's why. So I'm going to move this onto that screen. And then we are back. Okay. So first step, what do we do with all these descriptions? Okay, so let's go ahead and write it out. So we're going to do, I think I actually have these animated. Maybe. One triangle is the same as 4 squares. 2 triangles is the same as 3 arrows. 5 squares is the same as 1 star. So then the question is, what do we do with them? And the reason that I'm doing this uber childish, you've noticed I do some kindergarten stuff in my classes, and it's really to reach back and think about why are we doing what we're doing, and let's take away all the complications of units. So for our purposes, these are units. So this could be centimeters, it could be pounds, it could be kilometers, it could be moles, it could be a whole bunch of different things. Now, I don't want you focusing on what it is that the units represent right now. I want you thinking about how do we go from one set of units to another set of units. So if we're trying to solve this question then, we have to pull out what unit are we starting with and what unit are we going to end with. So what unit are we going to start with here? Squares. And how many of them?
8.
Okay, so we have 8 squares. So we're going to do 8 squares over 1. That's going to be our starting quantity. We're always going to put the unit over 1 unless it's like miles per hour. If the unit is miles per hour, we'd have miles on the top. Per means divided by. Hours would be on the bottom. So double units would actually occupy the top and the bottom. Otherwise, it's always a 1 on the bottom. Okay, then we have to figure out how are we going to get to our final unit. What's the final unit we want to get to?
Arrows.
Arrows. Okay, so how many arrows? So how do we get from squares to arrows? How do we convert? Okay, let's go to triangles first. But the first thing I want to do is think about why this works. So I think I did describe this in the video, but if we look at, there's a conversion factor between squares and triangles. And I'm going to rewrite that out here. I'll erase it again in a second because I need the space. But if we have one triangle equals 4 squares, those things are equal to each other. So if we divide both sides by 4 squares, the same value, we didn't change either expression. Right? We didn't, in mathematical equations, we're not changing the equation by dividing both sides by the same thing. Is that okay? So we're dividing both sides by the same thing. We rewrite this expression. What is the left side of the expression? Nothing goes away, right? What about the right side? What happens to the right side of that equation? All right, here's a really key point of chemistry. And this is going to apply through this class and maybe some into organic and some other classes you have. In math, we can multiply anything by 1. And it doesn't change it, right? That means we can multiply anything by 1 triangle over 4 squares, and it doesn't change it, because that is 1. The only thing it'll do is it'll convert from squares to triangles, or triangles to squares if we flip it over. So whenever we write out these equalities, it's a way of saying, well, this equality tells us that we can multiply anything by the ratio of those two, and it doesn't change what it is. It just changes the units of that thing. So like if I talk about how long this measuring stick is, I can talk about it in centimeters or inches. It doesn't change how long it is, but we can convert between those two using a conversion factor. 2.54 centimeters is equal to 1 inch. So I can talk about it as 100 centimeters, or I can talk about it as 254, no, other way around. 100 divided by 2.54? So that's what, like 30-some inches? Ish? 39.4 inches. It doesn't change what it is. We multiplied it by a conversion factor. It converts how we describe it, but it doesn't change it because we multiplied it by 1. And we can do that for every single one of these equalities. No matter what the equality is, we can always do that. And we end up with new equalities sometimes after these problems, and I'll show you that in a minute. Okay, so I shouldn't have written that so high. I'm going to go ahead and erase all of this. So then let's go ahead and make our first conversion. We know that we can convert from squares to triangles. So what am I going to have on the top and what am I going to have on the bottom?
Squares on the bottom.
Can I have volunteers? And we'll kind of pop around the room. Go ahead, Sarah.
You put squares on the bottom, 4 squares, and then 1 triangle on top, because you need the squares to cancel out.
Okay, so what we're trying to do here, mathematically we're trying to cancel units out. The terminology I want us to use in this classroom is I want to convert. So we multiply by 1 triangle over 4 squares because we are trying to convert from squares to triangles. And mathematically that's because they cancel the units, okay? So that terminology of converting between is really important. And then can I have another volunteer? What would we do next? How would we get closer to our answer that we want, which is how many arrows? Kayla?
Maybe 3 arrows or 2 triangles.
Oops. So 3 arrows over, what'd you say?
2 triangles.
2 triangles. Where'd you get that from? Okay, so specifically, you looked at this equality, and you said, well, if I have 2 triangles over 3 arrows, or 3 arrows over 2 triangles, we can multiply anything by that, and it might convert it to something else. So that's this fraction that you have written here, this conversion factor. And then if we look here, triangles are on the bottom and the top. So like Sarah said, that allows us to cancel them out, or what's the other way we describe that? Allows us to convert from triangles to arrows. And then what next? Savannah?
Multiply across.
Okay, we don't have any more conversion factors we want to use?
You're already to arrows on the top.
Great. All right, so there's a whole bunch of pairings out here. We didn't need any of these for this problem. You're going to have extra information. You need to be able to look through that and pick out what it is you actually need. And so here we would look that our units are now arrows, which is what we're trying to get to. So on the top, we'd calculate 24 arrows. On the bottom, 8. And there's no unit there, which is great, because we weren't looking to get to an answer that had units on the top and the bottom. Okay, so if you want a couple more examples of this, it starts off simpler, it goes a little more complex. That's that video that's on our assignment page for yesterday. I might put it up on our class links in that playlist as well, so you can get to it. But basically it's this, and it's about 15 minutes of working through a couple problems like this. If we can keep in mind the conversion of these equalities to these conversion factors, and then using the conversion factors appropriately, making sure that we write out every single step, you're going to find general chemistry much, much more straightforward, because you're not going to get lost in a whole bunch of numbers and forgetting what units were there. Those squares and triangles, those are units. So whenever you're in class or at home working on these problems, we want to see you writing out the full units, top and bottom of each step, because that's going to help us see how you're thinking through the problem and make sure you don't get lost in the details. This is a relatively simple problem compared to in about a month and a half from now. We're going to be doing stoichiometry, and that might involve 8 steps or 9, 10 steps. And so I saw a lot of people trying at first to just do an equality, to do a proportion. So if you want to do it 1 step at a time, right? Sorry, that's supposed to be a square. Or we could do a question mark here, right? And then we could do 1 triangle over 4 squares. And you could say, okay, well, I can figure out how many triangles that is based on, well, I totally messed that up, didn't I? So we had 4 squares, 1 triangle. Based on this ratio, how many triangles is this? 2 triangles, because you do proportions, this times this divided by this, or however you want to do that. Yes, mathematically that works, but if you're doing 8 steps, you're not going to do this for every single one of your 8 steps. You're going to get lost, you're going to lose track of sig figs, which is another thing that Sam will be talking to you guys about today, or whoever you're in lab with. You'll spend some time talking about sig figs. And it is extremely important, especially in lab, to worry about what is a significant number and what is not, and you lose it every time you do individual steps. Any questions on this approach? All right, so we are going to shift gears a little bit. There's a couple of logistics I wanted to make sure to chat about. If you haven't already gone to lab, is today the first day of lab, or was yesterday? Yesterday. Okay, so labs are up and running. You will be joined by your graduate assistants for the most part, your TAs, and they'll help you kind of wrap your head around some basic laboratory concepts as well as significant figures. We already talked about discussion. Syllabus quiz is up and live. I think people got through that pretty much the first try, but if you don't, it's just a matter of using Control F. There's links to the syllabus, so you can download it. It's just a reference document. That's all I want you guys to do with that quiz. There are also a set of practice questions. One of the best ways to know if you know something is to go test yourself. I'm setting up this course from scratch in OWL, and so I'm spending a lot of time on the 4-credit assignments. So I just asked if they could take the back of chapter questions and dump them into a practice bin. We are not necessarily using all of the questions and all of the encyclopedia that is your book. So just be careful when you go through here. If it seems like there's a topic that we haven't touched at all, just skip the question. but I wanted you to have an extra set of resources. It's much better than going to the back of the chapter questions because these are algorithmic, which means it'll actually change the number, and which allows you to test yourself a little bit better than just having the same question as the back of the book and then looking up the answer. It'll give you coded feedback, and it's a pretty decent setup. So those are totally optional, but highly recommended. We'll talk about it more throughout the semester. I saw a couple people had an OWL, their Gmail account or something like that. If you want to if you can put your UALR, just go in and change the settings. That will make sure that I can give you credit for your work at the end of the semester and multiple times when I'll pull in your grades. I think your T number is really important, but also your email, and make sure those match up in case one is a letter off or something like that. We talked about this, that OWL, the first pre-quizzes were due today at 9 a.m. I'll extend that deadline until midnight so that people can get in, make sure they can work in the system. I'm curious how long it took. Let's do a clicker question. Where is it? Can you go ahead and enter... sorry, let me stop that. Let me re-enter. Enter in blocks of 15 minutes about how long it took you. So 15, 30, 45, an hour, hour and a half, whatever it is. You just enter how long it took you to complete the pre-quiz, the pre-class quizzes, if you got to complete those. So just type in a number, 15-minute increment, hit send. You guys a couple more seconds to enter that. All right. How do I leave? Okay, so it looks like half the class said... No, percentage, sorry. 15 minutes, lots at 30. Okay. And there are numbers. I'll go through and look at the numbers as a whole. But a big thing that I want to make sure is that I'm not overburdening you. The idea of these adaptive quizzes is that you should be able to take the quiz. It should give you an idea of what things you might not be great at yet, and you can go read up on those, come back and take the quiz over again. I think it was initially set up to do 3 attempts. We're going to try doing unlimited for a while. See how that works. If people just game the system, and then I'll change it back to 3 attempts. But that's ballpark. I want you to spend on these about 30 minutes before each class to make sure you have some of the basics. If you really don't know the material, it'll take you longer. If you've already seen it before, it might take you 2 minutes. And that's totally fine by me. There are also homework assignments for the week, and you'll get your homework assignment on Friday that will start in class that you'll complete over the weekend. There is one pre-class quiz and one video to watch before class on Friday. I'll make sure that it shows up as a video that's due Friday to make sure that's easy to see.
I think it was, she said something like you clicked a different tab, and since it didn't have a due date, it didn't show up on the one that automatically pulls up. Okay, so the All Assignments tab is useful for that. I'll try to also help and make it show up on your calendar as well. And for reef polling and Cengage, I think your T number is going to be important. All right, let's get into some conversations here. I want you to go ahead and read these 5 statements about climate change so I can get a feel for what your perspective is coming into this class. Your clickers are open.
looks like we have a distribution. Looks like 2 is pretty significant. All right. So one of the course goals that I have listed for this course is, it's killing me with this giant screen thing. At the conclusion of the semester, students will be able to explain the phenomenon of global climate change from the molecular perspective. The chemistry course has been described in the past as a weed-out course, or just like a course you have to get through. And I want to show you guys why it is that chemistry is really important to understand the world around us. It influences the way that we vote. It influences the way that we live our daily lives. And so climate change is a topic that I've spent a lot of time studying. And I want to incorporate our knowledge of chemistry and how it applies to this topic. So specifically for today's class, with the time that we have left, I want to make sure that you will be able to predict future temperature trends based on historical data, describe the carbon cycle, identify and apply conversion factors for mathematical representations or sentences. That's what we worked on in the first part of this class, but we're going to be applying it to some climate change stuff as well. And that's also involves restate written relationships in a mathematical representation. And we'll be working on that more on Friday, basically how we take the relationships, those mathematical ones we saw at first, and how we describe the conversion instead of the canceling, that kind of stuff. What do you guys think about this statement? All right, closing up. Ooh. I think we have 58 in the class. Are you clicking in, Sam?
Yeah.
Okay. So maybe we have 59, but that's pretty awesome. It's always interesting, right? So we have a distribution. There is a majority answer of false. Why is this an important question when we're talking about climate change?
Because if that was true, then you know it wouldn't be significant in terms of actually us causing it.
Yeah, and so if we take a step back and we look at the planet, it looks like there's not much. It looks very different than it does from down here. Avery, you want to add something to that?
Yeah, because a lot of times we forget about greenhouse gases, and greenhouse gases basically can be described in chemistry based on the elements that compose them, which go into the atmosphere and change the air quality. If you look at China especially.
Yeah, and I think the big question that I'm trying to drive at is how relevant are those greenhouse gases, kind of adding together your guys' points. And so if we stand down here, everything that we see if we look up is atmosphere, and it's gases, and it looks enormous. But if you step all the way back here,
it's not.
you kind of get a different perspective of how big the atmosphere is that wraps around the Earth. And so this, while it is ginormous compared to us, is a very thin coat of gases that wraps around the planet. So the question is, how do we influence that? And how do other things influence it? It might not just be us. It's not just us.
And I think it's even worth more noting that that most of that isn't actually isn't actually very thick atmosphere. The very thick stuff is about maybe 1 pixel on that image.
Right. So a lot of the stuff out here is much less dense.
It's much less dense. In fact, it's probably not even dense enough to support human life.
So I want you guys taking a look at some data. And I want you first to think by yourself. So we're going to do a lot of think, pair, shares in this class. I'm not sure if you've done these before, but it requires you first to think, what is my own opinion about this? What are my thoughts? After about 30 seconds or a minute, then you turn and pair and talk to someone else. And then after that, I'll ask for some report outs from the pairs. So here's some data that comes from NASA and what does it say at the bottom? Earth observatory.nasa.gov is where this data comes from. Anyone like me to read the axes?
Yes.
Okay, so the axes are years before present. That's the x-axis, so it starts at 800,000, goes to 0. And then the y-axis on the bottom one, it says Antarctic temperature in degrees Celsius, -10 to 5. And then carbon dioxide is listed in parts per million. That's 200 is here, 300 is there. So go ahead and think for yourself, what information is conveyed here? Once you've thought about that for a while, pair with someone else, 2 or 3 people, and talk about what you think this conveys.
We only collecting data off of rocks and stone.
Who are you pairing with, man?
I mean, I don't know. I pretty much got it. I mean, I think I don't really have much to talk about it.
No, but I want to hear what can you pull out of the data?
I mean, they're...
Turn around and chat with these guys.
All right.
Make sure to...
Oh, I had a question.
Yeah.
So this is our book, right? This is it?
That is, yes.
That's the whole book. Is there like any like textbook part of it, or is it just like the owl stuff?
So you can actually get a...
Carbon dioxide goes up.
You have them send you a paper copy of it, print out copy for like $7. Just pay for shipping.
I was in the Army.
Oh.
So I have to figure out how that applies, but there's an option for that.
We can either buy it as an ebook or ship it from that website.
Yeah, somehow through the website you can get a copy. Huh? Yeah, online version comes with it. You can also get a paper copy. It only works so well if you're talking to people beside you and I'm behind you. All right. What information is conveyed from this? One piece of information at a time. Can I hear from someone who hasn't spoken yet? Raise your hand, please. Go ahead, Kiana.
So it seems like as carbon dioxide increases, the temperature increases too, so they kind of move in unison.
Great. So as the concentration of carbon dioxide changes, so does the temperature. So there's some sort of relationship between this. Great. Can I have another hand? Lloyd?
Well, actually, there's a direct correlation for the past 800,000 years, which, as the data shows, is not a coincidence that it's happening, because every single time the concentration went up, so did the temperature, and as soon as it went down, so did the temperature.
Okay. So it might be more than just interestingly related. There might be a causal factor to that. And I think if we get into talking about some more specifics, we might get more into that. What else? Christina?
I like to point out we're talking about humans causing, the temperature increase and all that. But if you look at it, there's multiple temperature increases, which shows that it might be more natural.
Okay.
Like supernovas or something erupting during that time.
Yeah, so there's a very strong argument that people say, if you look back historically, that humans weren't really prolific during these time frames, and the temperature changed. The carbon dioxide levels changed. Go ahead, Jackson.
I hate to say this, but that graph is kind of wrong because it doesn't say that we've already surpassed 400 parts per million carbon dioxide. So
it's not a complete graph. Okay, so hold on one second.
So until it does, I'm not believing it.
We're just about to get there. Okay, so I think the main take homes from the data that we see right here is that we have cyclic nature of carbon dioxide concentrations and temperature. They correlate to each other. And over very long periods of time, this relationship has been observed. Do you think we had weather monitoring stations during these time frames?
No.
Anyone know how we actually got this?
Ice cores.
Matthew?
When they drill ice cores out of the Antarctic.
Yeah, it's just crazy. Until I saw a few videos on it, I didn't quite wrap my head around it. Literally, as snow falls in the Arctic, in Antarctic, it traps little bubbles of air. And then as more snow falls, if it keeps falling, those bubbles of air get trapped. And so they end up getting compressed at the bottom of glaciers, and if we go to places where the glaciers are deep enough, we can actually drill back and we see like rings of a tree. We can see year by year what the air was like at that time. So we can actually go back, some glaciers are deep enough, we can go back 800,000 years and look at what the air was like then. And then based off of the ratio of some of the components in the air, the oxygen isotopes, that we'll get into at the end of this week, or beginning of next week, you can actually tell what the temperature was then as well. And so, as Jackson was hinting at, this is not the full graph. Let's see if we can actually get it to go forward. That time 0 was actually right here. So I was being sneaky, and Jackson wasn't letting me get away with it. So what's different here about this graph? Go ahead, talk to your neighbor for a second. Try to unpack what's going on here at this end of the graph.
It seems to link us a lot, and then whenever things started really showing their pulsar field stuff, it really began to get bad because it shot up. Time 0 is now. This is probably the time people past. See, 0 equals 1950. So, if that looks bad, that's because it is. And there's also, as I said, methane, which was doubled in concentration over like 50 years.
Alright, can I hear from a new voice? What did you guys discuss about this? New voice. Great, Angel, thanks.
It's a huge exponential change, which means it's going pretty much straight up. And
Since
the 1950, I mean. And it's directly related to the growth of the population. And
okay, pause. So that let others add as well. So we heard a little bit from your group. Thank you. Tyler?
Industrial revolution.
Okay. So yes, it's related to human growth, but more directly it's related to industrial revolution. Love?
It's also more about like agriculture too, because our agriculture also went up, like farming, breeding animals, and especially like cow farms. It's over. There's a couple trillion cows on Earth. I'm pretty sure they produce just as much emissions as.
Yeah, so it is a very complex system. One of the parts is industrial revolution, which allowed us to do more agriculture, which has a large impact. Kevin?
Where was this information gathered from? Like, where was the accuracy tested specifically? Because the other graph was comparing to Antarctica.
So most frequently, the gas samples are taken away from human population so that you don't actually get the direct impact, but you get the global impact of how the concentrations change. So the Antarctic is a very common place to collect that. Jackson?
I think it's worth noting that carbon dioxide is not the only greenhouse gas. The fluorocarbon refrigerants that we've been using are not only 100,000 times worse than carbon dioxide in terms of absorbing stuff, they also last for 10,000 years on average.
Yeah, and so there's a lot of complexity to this system, and one of the pieces is CO2. And so we're trying to think about human impact and kind of how that all relates back. And so that relates to a number of different things. What is the balance between carbon being released since the Industrial Revolution and methane and all these other things versus how much is being absorbed? How is that balance potentially being perturbed? And what does that mean about our impact on global climate? And so one of the major conceptual points, by the way, you'll notice that I go exactly to the end of class every time. So if you're packing up, please hold that until right at the end, because it ends up getting a bit loud. So if we just kind of think about carbon dioxide, and okay, as the levels change, somehow temperature goes up, it's kind of vague. So I think Avery mentioned earlier that you can think about the atmosphere as kind of a blanket or a greenhouse, right? In a greenhouse or in your car, a lot of light goes through, and some of that heat.
A lot of the infrared light gets out.
Right, so a lot of the heat doesn't escape. And so that means that your vehicle gets a lot warmer than the outside temperature. And the same thing happens to our planet. As that glass lets out less heat, as the atmosphere lets out less heat, that means that our planet warms up. And there's a lot of things that absorb that light, that heat that comes off. There's methane, there's a lot of artificial chemicals that we're putting out, and carbon dioxide is one of the main ones that we're going to be talking about for the sake of chemistry. And the reason why is because we can look very directly at what our impacts are on carbon dioxide. We can think about that as individuals. So if we look at the cycle of carbon, there's a lot of different ways in which carbon gets into the atmosphere, and a lot of different places where it changes location. So these are some of the major ones. Maybe talk to your neighbor for a second and think about how these four places right here, how do they interact with carbon dioxide? Do you think they absorb carbon dioxide, release it? What do you think the overall change is every year? Talk for 1 minute to your neighbor. Okay, so biosphere, it's like the living things in the planet. What do you think? Does that overall take in CO2 or release more CO2?
I'd say it's neutral.
Say goes up, it puts more carbon dioxide out there, takes up more carbon dioxide than it releases. Go ahead and raise your hand if you think it takes up more, or is net neutral. Okay? So overall, it typically takes in more carbon dioxide, so it decreases carbon dioxide in the atmosphere. What about the oceans?
Big decrease. There's a lot of phytoplankton in there.
So the oceans do suck up a lot of carbon dioxide. They convert it into carbonic acid, leads to ocean acidification. What about fossil fuel burning? All right. And this is talking about how many petograms, 10 to the 15th grams of carbon per year, are either released or absorbed from these sources. Deforestation. It's not talking about agriculture, not talking about all this other stuff. We're only talking about carbon dioxide.
That's already...
And so right now, in our current use of the environment, we're releasing a significant amount more than is being taken in by illicit sources.
Twice.
So there's a lot to think about here. For Friday's class, please make absolutely sure that you watch the video before you come. If you can't find it immediately, look at all assignments, and then we have the one pre-quiz. And if you have any logistic questions or whatever, feel free to come up and talk to me after class. I'll try to pack up and we might have to move into the hallway. Oh, sorry, one last thing. The piece of paper I handed out is called a reciprocal interview. I want to know about you guys and how to help you succeed. And if you have any questions for me, I want you to turn those in. So please do that at the beginning of class on Friday as well. If you want. You don't have to turn it in, but if you want me to know something or you have questions for me, fill it out.
Where would turn this in?
Beginning of class on Friday, please.